Alright, in this lesson we are still in section 1.3 of Stewart's Calculus, Early Transcendentals 7th edition if you're following along, and I'm just going to go over function transformation, specifically stretching, compressing, and all that good stuff with some trig functions. In particular, the sine function. The sine function. Okay, and the domain of sine is all real numbers from negative infinity to positive infinity, and the range is from -1 to 1. Okay, and the sine function starts off through the origin, goes up, curves, goes down and over, goes down, like that. So that's sine. And actually what I'm going to do to illustrate these transformations is to pull up my grapher application and just show you. So here's sine, like I said, goes through the origin, and let me change the frame limits. There. And also let me change the this to pi units. There, okay, so as you can see, it has a period of 2 pi. Okay, for every 2 pi it repeats the graph of sine repeats itself. And its range is from 1 to -1 and infinite domain in each direction. So now that's sine. And I'm going to illustrate the stretching and compressing by manipulating the equation of the graph of sine. Okay, so when we multiply sine by some factor, let's say 4, we're going to get a stretch, a vertical stretch by a factor of 4. And look, it goes up. And notice too that its x-intercepts are the same. So it's not a horizontal stretch or compression. It's a vertical stretch. Now what if we multiply our sine function by a constant between 0 and 1, like point, well, hold on, let me show you sine again, and then let me show you half of sine x. It's a vertical compression, the exact opposite of a vertical stretch. Alright, now for horizontal compression and shrinking. If we multiply the argument, in this case x, by a constant greater than or equal to, well, greater than 1, then you're going to have a shrinkage horizontally, like that. Notice, by a factor of 2, the x-intercepts changed. It went from pi to pi over 2, pi divided by 2. And if we multiply it, well, here's sine x, and if we multiply it by a value, the argument, in this case x, by a value between 0 and 1, we get a horizontal stretching. And you can see that it'll be a stretch of a factor of 2. In this case, it's 0.5 technically, but it's going to double the horizontal periodicity. So instead of instead of intersecting pi here, I think, was it pi? I forget. Yes, it was pi. So instead of intersecting pi, it now intersects 2 pi, pi times 2. And those are the only, oh, well, I want to show you something else as well. So when we make the entire function negative, we're going to get a reflection about the x-axis, like that. So this point up here, that was originally here, is now here, because it's reflected about the y-axis. Oh, I'm sorry. About the x-axis. When you multiply the function, the entire function, by a negative, it's reflected about the x-axis. So the point that was originally here is now here. And if you multiply the argument by a negative, well, it doesn't really show up on this graph, but it's a flip around the y-axis like this. So the point that was here is now here. And as you can see, the flipping about the y and x axis for the graph of sine is not evident if you flip from one to the other, because they're not the same, but they look the same. And even if we do it for cosine, you'll see this, and actually the negative, when the argument is multiplied by a negative, you get pretty much the same graph. But you do get a different graph when you multiply cosine, the entire function, by a negative, because it flips over the x-axis like this. And that's really all I wanted to show you for this video. So stay tuned for more.